Hello and welcome to part 2 of my Classicladder Basic Introduction series for LinuxCNC. In today's lesson, we're going to create a circuit in Classicladder that uses two physical inputs from our breakout board to supply the probe signal input to LinuxCNC, but uses a virtual relay to switch between the two inputs. So before I begin, I just want to give a brief introduction to what relays really are. A relay is an electromechanical device that's essentially a switch. That switch is actuated by an electrical input that energizes a coil that creates a magnetic field and moves an armature from the normally closed position to normally open position. If that electrical signal is deactivated, the armature will return from the normally open position back to the normally closed position using a spring. These are great little devices. The only downside to them, or one of the only downsides to them, is that they are susceptible to mechanical failure. The spring can break, the armature can break, carbon buildup between the contacts can cause it to essentially just fail out. So to get around using relay after relay after relay inside of an electrical cabinet, we have now PLC ladder logic that can eliminate a lot of the physical relays and trade those off for virtual relays. And that's what we're going to do today. On my CNC router, the tool setter and my spindle probe are tied to the same input using a relay. And again, the downside to that relay, and somebody had asked me last week, well, what do you do when that relay fails? Well, I'm going to nip that in the bud and create ladder logic and just use two physical inputs on my breakout board instead of using a single input and dividing that signal with a mechanical relay. So that's what we're going to do tonight. So now that we're ready to begin, we're going to go to our setting page, enable our HAL configuration using the HAL Show button in GMO Kapai. And I know that I want to create an output from Classicladder and send that data to LinuxCNC. So I'm going to go to my Classicladder section in my pins. I'm going to assign output 00 to my watch list. I know I want to use two inputs from my breakout board, so I'm going to view input 0 and input 1. I'm going to use input 2 as my virtual relay. I also know that I want to tie in the output 00 to my probe signal, so I'm going to go and I'm going to add probe input or motion.probe-input to my watch list. So really this is all we're going to need in our ladder circuit. I'm going to show you two ways to do this. There's a simple way and there's a simple with an asterisk over it way. The first way we're going to do it is the simple way. The second way we'll do it will be the asterisk simple way. So we're going to go into our editor. We're going to create our basic output circuit, hit OK, and we see that it lights up. That way we know we have connectivity between Classicladder and our HAL. From there, I'm going to create two inputs on the far left side, and that'll be input 0 and input 1. We'll connect those with a vertical line just for the time being. And what we have here is we have an OR statement. So the OR statement tells the output that either input 0 or input 1 can make the output go true. To see that, we can go to our test HAL command and do a set P Classicladder .0.in-00 true. And we see that the circuit gets completed. If I then set that to false and set the input 1 to true, we will then see that the circuit gets completed using input number 1. So essentially that is what we want to achieve, but we want to break the inputs or divide the inputs using a relay that switches between the two. So we're going to go back into our editor, modify, we're going to take out the vertical line. We're going to move that vertical line over one box. And in between input 0, input 1, and our vertical line, we're going to insert a normally open coil at the bottom, a normally closed coil at the top. We're going to name both of those I2. When we hit OK, we can now see that input 1 is still energized, but it's not completing the signal. We can see that the normally closed or the break contact of I2 is also currently active. If I do a set P to Classicladder.0.in-02 and call that true, you'll see that the circuit then becomes complete. If I make input 0 true, input 0 is now active, but it's not passing through input 2 because input 2 is currently set to true and the coil underneath is energized. If I set input 2 back to false, we can see that the circuit gets completed. Both of the inputs are currently active, but input 1 is being blocked off by input 2, and it's not letting it pass the signal. So essentially this is what we want. This is our completed circuit. Now we need to start tying this into our LinuxCNC inputs, and we could still do that with our HAL configuration. So what we're going to do now is we're going to start tying our inputs and outputs to our HAL pins to get everything to communicate properly. So right now I've got 3 active bits here on my watch list. I've got Classicladder out 0, Classicladder in 0, Classicladder in 1. I know that I want to tie my output to my end result, which is motion.probe-input. So we can do that in our test HAL command. And again, remember, whenever you get a working HAL command under the test HAL command area, always copy and paste it into your HAL file to make sure that you don't have to do it over and over and over again. So we're going to do a net probe-in, and we're going to say Classicladder.0.out-00, and we're going to tie that to motion.probe-input. When I go to my watch list, you'll then see that motion.probe-input is active because now it's tied to Classicladder.0.out-00. When I click on the ladder symbol, I'll see that the HAL signal is probe in. Let's disable the inputs. We'll say set P Classicladder.0.in-00 false and -01 false. Go back to our watch list and we can see that everything now is disabled. So the next thing we're going to want to do is we're going to want to tie our input signals 0 and 1, to our input signals coming in from LinuxCNC. This being a simulator, I don't have the breakout board pins that I would connect to. On the G540, I would use the PAR port pins, and on my Mesa card, I would use the HM_2-7i76E input pins. But in the simulation, I'm going to use the digital ins 0, 1, and 2. So the only difference between this example and real world is that your input pins 0 and 1 are going to be different depending on the hardware that you're going to be using to configure your ladder circuit. Inputs 2 are going to use digital out 3 in this case. Oh, sorry, digital out 3 in this case. And digital out 3 is going to be controlled by the M64, M65 commands within LinuxCNC. So to do that, I want to net the input 2, so we'll do net, we'll call that relay, and we'll say classicladder.0.in-02. We're going to tie that to motion.digital-out-03. Once we do that, we can go back to MDI. We can do an M64 P3, and we'll see that the input has now changed from the break coil to the make coil, or the normally closed coil to the normally open coil. When we go to our HAL configuration, we go to our watch list, we'll see that classicladder.0.in2 is now true. And that motion digital out 3 is also true because they're tied together. At this point, I would use the M64, M65, P3 to toggle between the two. To test if the rest of it is working, we'll go to our little test area here, and we'll do set P, classic ladder .0.in-01 true, and so far it's not working. So what I want to do is trigger the output, and we'll already see it's making the circuit because we're using the outputs to trigger the virtual relay to complete the circuit. So again, the difference between software simulation and the physical hardware is going to be in our I0 and our I1. In this example, I'm just going to tie those to the digital inputs 0 and digital input 1. So to do that, we're going to say net, and we'll call this tool -probe, and we'll net this to classicladder.0.in-00. We'll also net it to motion.digital-in-00. In the test HAL command, if you don't complete the net, as long as the name is the same, you don't really have to delete anything in the line. You would just add to it. And we would see here, classic ladder in 01 is active. If I click on here, we have tool probe, which is input 0. I'll go back to here, I'm going to set my net name to spindle probe, and we're going to tie that to Classicladder in 1 and motion digital in 1 as well. Go to our watch list. Our motion digital in is now active. Classicladder in 1 is active. Motion probe input is active. So everything seems to be working the way we like. Now the set P is not going to let me change Classicladder .0.in-01 to false. It's going to give me an alarm. Now that we have a completed net signal, we now have to change 0 and 1 by their signal names. If we go down to the bottom and we look at our signals, if we don't see our signals pop up after we net them, we can close out our HAL configuration, open it back up, and that'll refresh the configuration. So we go to our signals, scroll down, and in this case, go to our watch list, we'll see spindle probe, tool probe. Yes, I have to re-establish all of my other signals if I want to watch those. But now we would use the set S command because the signal is complete. We'll set the signal of tool probe to a 1. We'll see that it's active. Set it to a 0. We'll see that it's inactive. The input 2 relay cannot be commanded with the set S because it's tied to the M64, M65 command. So it's going to yell at me when I try to set that to a 0. So I could just go back to MDI, M65, and I still have my completed circuit. So I did say that there's 2 ways that you can do this. You can do this the easy way that we just did, or you can do it the easy with an asterisk way, which is still fairly simple, but it uses a little bit different logic. We're still going to use input 0, input 1, input 2, output 0, but we're going to command all of that in a slightly different fashion. So what we're going to do in this case is we're going to create an output line at the top. We're going to call that B0 to utilize one of the internal relay bits. Then we're going to create our circuit with our output 0. Hit OK, go to our HAL configuration, and we still see that it's happy. So going back into our editor, we're going to create a coil up here of input 2. We're going to tie our input signals together again here. Connect those with a vertical line, and we see that we have both of the inputs are turned on and the output still firing. We're then going to add a normally closed and a normally open contact labeled B0. Hit OK. And we'll see that functionally this is going to work the same way, where it turns off and turns on this relay coil based on the status of this output. So we're technically bringing in the output from input 2, sending it to an output here, and then sharing that output between a different part of the ladder in a totally different circuit. And you can see that here. You can see it more clearly if I turn off one of those inputs. So I'll go to my HAL config, show. We'll say set S tool dash probe 0. So now we have our B coil energized in the normally closed state. We'll fire the input M64 P3, which again is up here, finishing the circuit down to here. The reason to do this is a couple-fold. You can utilize the same output in different scenarios. It's also good for troubleshooting to see the physical output being triggered on a separate rung. Another thing that it's good for is tying in numerous bits of safety into this circuit. If I wanted to add a spindle inhibit or something like that, I could add a logical I/O into this string and make it so that it can't fire until all of those status inputs are met. So it's helpful in a way because, again, it allows you to create safer logic. I do know, because I've done this already, that if I select my input 1, get rid of that. If I select my input 1, I've got spindle-probe. I have a free pin that I can assign to my input 1. And if I go to my HAL configuration, spindle 0 inhibit. So what I can do is I can net spindle-probe to spindle.0.inhibit. That will tie input 1 to the spindle inhibit so that when input 1 is made, the spindle won't turn on with the probe in the spindle. It locks it out. And I tested this last night on my machine and it works fine. It also locks out M3 functionality. There's a guy on the forum that said that it still allowed M3 to pass, but in my case it did not allow the spindle to turn on. So again, you can do it one of two ways. You can use it to trigger its own output line and then use that output as an input on another section of your ladder, or you can just do it the way we did in the first example and have it just internal to that one rung. So I hope this is helpful. Thanks for all of the positive feedback from the first video. It definitely inspired me to continue on, learn more information so I can share it with the community. Don't forget to like and subscribe to the channel and keep an eye out for more content. Thanks for watching.